Hello friends, this video on application of derivatives part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 9. We have to again find the value of x for which my this equation is increasing function. Why I am taking this because I wanted to solve one more question where you get f dash x as a quadratic equation so that you understand how to solve the inequality question. So here also y is equal to nothing but fx, you can say, right? So first thing I have to do is I have to find f dash x and I have to find the value of x for which f dash x is greater than 0, greater than equal to 0, because it is increasing function. It is not strictly increasing function, correct? So that is my fx is equal to if x into x minus 2 whole square. So let's factorize this. So this becomes x square minus 2x whole square, and this is nothing but x4 plus 4x square minus 2 into 2, 4x into x square is x. This is the value of fx. So my f dash x will be nothing but this will become 4x cube, this will become plus 4 into x square will become 2x, 4 into 2x, that is 8x minus this is x cube actually. So this will become 4 into x cube become 3x square, 4 into 3x square, that is 12x square, correct? And if you take common, this is nothing but 4x into x square minus 3x plus 2. So this is my f dash x. So let's solve this now. F dash x is this value, and that is nothing but 4 into x minus 0 into this. If you factorize, you will get x minus 2 into x minus 1. Now this is my thing. Now I'll take my case. There's only one case here. My fx has to be greater than equal to 0. That is my 4 into x minus 0 into x minus 2 into x minus 1 has to be greater than equal to 0, correct? So let's take the number line. In this the breakpoints is 0, x minus 0, x minus 2, it is 2, so 2, and x minus 1, that is 1. So I'll take this guy as 1, this guy as 2. I'll get more space here. So 0, 1 and 2 are 3 breakpoints here. Now where I have to find where the values are positive or negative. I can take any number. For example, let me take value as this guy. Let me take 3 as the value this time here, right? So I put 3 here. This becomes 4 into 3 minus 0 is 3, 3 minus 2 is 1, 3 minus 1 is 2. This is a positive number, so that means this side has positive values, this range will have negative, this will have positive, and this guy will have negative. I am interested in the positive range, so I am interested in this guys and this guy, correct? So that means x is member of 0 to 1 and 2 to infinity. Now if you see, since it is greater than or equal to 0, I'll have this as closed interval because I'm including all these values. Please note why it is a closed interval, because it is greater than or equal to 0. Has this been a strictly increasing function, I would have written an open interval, correct? But since this is a case where this is increasing function, I don't write this, I write this. Please note these are small things which you should understand, else you will get incorrect answer. In case of closed interval, you include the values. So in this case 0 and 1 are included, 2 and infinity is included, but in case of open interval, these extreme values are not included. For example, 0 and 1 is not included, 2 and infinity is not included. If you don't understand this, watch my video on these. I have a video where I have explained all these intervals. There you can get the concepts clear. Let's take one more example. This is a pretty simple example. We have to prove that the log function is strictly increasing from 0 to infinity. So my fx is equal to log x. I have to prove that for any value of x from 0 to infinity, this is increasing, strictly increasing. So very simple. I have to find f dash x. I have to prove that this guy is always greater than, this is greater than 0, strictly increasing, for any value of x 0 to infinity. That's all you have to prove. My f dash x is nothing but 1 by x because fx is equal to log x, and this guy will always be greater than 0 for any positive number of x. You take any value of x, 1, 2, 3, 0.5, right? Take any value, this guy will be greater than 0. and thus I can say that my f dash x is always greater than 0 for any value of x between 0 and infinity. Please note, I am taking only 0 and infinity, because if I take a negative value here, this becomes less than 0. So in that case, the condition fails. So in this particular domain, this log function is always increasing, strictly increasing. Let's take one more example. This is a function where we have neither increasing nor decreasing kind of function. You have this function, and to prove that this function is neither increasing nor decreasing in this range, so very simple, same thing, find f dash x. This comes out to be x square becomes 2x, x became 1, right? 2x minus 1. I have to prove that this guy is sometime positive, sometime negative in this domain. So if I take something that is between, let's suppose, -1 to 1, there are so many values. I have 0, I have 1 by 2, I have -1 by 2. So let's take -1 by 2 here. So this becomes 2 into -1 by 2, correct? -1. So that is -1 minus 1, that is -2. So here if you see the negative value, let's take 1 by 2. 2 into 1 by 2 minus 1. This is 1 minus 1. It has a 0 value, correct? Let's take 3 by 4. You take 3 by 4, this becomes 2 into 3 by 4 minus 1, that is 3 by 2 minus 1, that is 0.5, and that is a positive value. So if you see in this domain itself, sometimes I'm getting positive, sometimes 0, sometimes negative, right? So that means I can say that in this particular domain, this function is neither increasing nor decreasing, correct? Let's take a different example here. Here we have to find the least value of a such that this function is strictly increasing on this particular range. Here the question is a little different. Here have to find the value of a for which this function is strictly increasing. For the first thing you have to do is you have to find f dash x, because if f dash x is greater than 0, then only my function is strictly increasing as mentioned. So my if fx is x square plus ax plus 1 as given, my f dash x will be nothing but x square becomes 2x, ax becomes a, and 1 becomes 0. So this is my f dash x. This has to be greater than 0, correct? That means my x has to be greater than minus a by 2, correct? Or since we have to find the value of a, let's take this way. Let's take this way. A has to be greater than minus 2x, correct? A has to be greater than minus 2x. Now the value of x is from 1 to 2. So if you take the value of x to be 1, let's suppose, a has to be greater than minus 2 into 1, or a has to be greater than minus 2. The second condition is x is 2, a has to be greater than minus 2x, that is 2 into 2, or a has to be greater than minus 4, correct? And you have to find the least value of a which satisfies this. So if you take the number line, you have minus 2 here and you have minus 4 here. The first condition says a has to be greater than minus 2, that means a can be any of these values. The second says a has to be greater than minus 4, any of these values. The condition which satisfies both of these, please note, the condition which satisfies both of these is these guys, because both match. So that means a has to be greater than minus 2 is my condition. It has to be greater than minus 2. That means if this is true, the function will be strictly increasing. Now if a has to be greater than minus 2, I have to find the least value. So least value will be minus 2 itself. See, I can take 5, 6, 7, 0, all these values satisfy the condition that the function is increasing function. But I have to find a minimum value of a for which this function is increasing function, and that value will be minus 2. Why? Because this is my condition. So a is equal to minus 2 is minimum value. A is greater than or equal to minus 2 is a general value, actually. General value of x a for which this condition is, this function is increasing function. But we are asked the minimum value, so my a is equal to minus 2 will be my answer. See, very simple. Nothing great in this. I just found f dash x and I made it greater than or equal to 0. With this, I got two value of a. First is a is greater than minus 2 and second is a is greater than minus 4. The trick here was using this because a lot of people don't know, a lot of students don't know how to use this. if there are two inequality equation, you have to find one by merging these two. The best is draw a number line. So you have a is greater than -2 and a is greater than -4. Draw the number like this, line like this, and the one which match both is the one we are looking for. Correct? In this case, both the lines are in this range. So a is greater than -2 is the condition which is formed by merging these two conditions, and the minimum value is a is equal to -2. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.